So today we'll start with the RTL design using Verilog. Okay. Yeah. So Verilog. Um, so RTL design using Verilog. Before going into the Verilog, we have a programming languages. No, programming
Hmm.
languages. So programming languages are categorized as one is software language, software programming, and next one is hardware descriptive language. Hardware descriptive language. So this is nothing but HDL. We call it HDL. Okay. So software programming means what are the software programming languages?
C++,
C,
Python.
C++, Java, and Python. These are software programming languages. Okay. And hardware descriptive languages are nothing but we have Verilog,
VHDL. Hmm.
yeah, VHDL. So what is the full form of VHDL?
Uh, Verilog hardware descriptive language.
Very high speed integrated circuits, hardware descriptive language. Okay. And next you have system Verilog. System Verilog. Now my question is, what is the difference between software and hardware descriptive language?
This HDL we use for digital, like this HDL we use to for the coding for the chips.
Hmm.
That software, like we use it for normally, like for the software thing.
Okay. So software means what? They will not create. Means they will not design for the hardware. Just they will
Hardware.
they will use they will give the application. Okay. Suppose software languages they are using Java or Python or C sharp for any like bank related application or like railway ticketing. They will make the application and they will give it to the client. They will not make the hardware. Okay. So by using this hardware descriptive language, we can make the hardware. We can make the hardware.
Hard.
Okay. That is nothing but there is a term called synthesis. Synthesis is nothing but we are converting your code into gate level netlist. Gate level
Right.
netlist. Okay. So that is the difference between this software language and hardware descriptive language. And mainly this is sequential. I mean, this is serial in nature. Serial in nature means what? So one after the other instruction that will be executed serially, and these HDLs are concurrent. These HDLs are concurrent. Concurrent means what? That will be executed parallelly.
Parallelly.
This will be executed parallelly. Okay, so parallelly, and like you have VHDL, I told you, no, very high speed integrated circuit hardware descriptive language. So you can ask what is the difference between this VHDL and Verilog. This is highly secure, and it is came into market around 1999, and mainly this is used for defense only. Used for defense. Okay, and here VHDL very uh, complex syntax will be there. Okay, a complex syntax, and it will follow the old language like Ada and Pascal. Ada and Pascal. So for VHDL, so suppose if you want to write
No, sir.
the.
1 minute. I'm getting call from someone.
Okay,
After 10.
okay, okay.
Yeah. Hello.
Yeah.
Yeah, sorry, sir, for the
Okay, okay, sure, sure, no issue. So this is having the complex syntax, and separately you need to declare the header files like IEEE, that header files you need to declare, and in the entity you need to declare the inputs and outputs, and in the architecture you need to write the Verilog, the log,
Hmm.
whatever the logic is there, that you need to write. Okay. So here our attention is not VHDL, our attention is Verilog. Okay. Verilog. So Verilog, that is came into market. There is an IEEE. IEEE, they will standardize these languages. So they standardize this language by using in the year 2001. Okay, 2001, and so here next you have by using Verilog we can design your these ASICs are there, no, application
Ah,
specific integrated circuits. The
integration.
ICs ICs which are used for only specific application, that we will design RTL engineers, that they will write the code in Verilog. So mostly for the FPGAs we use this VHDL. FPGA is a configurable. I think you studied about FPGA. What is field programmable gate
Field
arrays?
programmable gate array.
Gate arrays. We already studied PLDs, no? Programmable logic devices.
PLDs.
PLA, PAL, and PROM,
PLD.
and CPLDs and FPGAs. So these are the families of PLDs. Okay. And next, system Verilog. System Verilog is also a HDL. Okay. Mostly, why you are using system Verilog? You have idea? Any idea?
Uh, as of now, it's for verification.
Yeah. So that
Like
means
if
by using system Verilog also you can use the you can use for design.
design, yeah.
Okay, you can use for design. Means 30% you can use for design. So most of the 100% you are using for the verification only. Okay. So nowadays designers are using system Verilog for the design also. Is it fine?
Yeah.
Okay. So here suppose suppose if it is Verilog is there. Okay. So Verilog, you know that we already seen the full adder. Full adder have how many inputs?
Three inputs.
Three inputs. So let us take A, B, and C in. Okay, you are getting A XOR, B XOR, C in.
Yeah.
Okay, so you know that this is sum equal to A XOR, B XOR, C in. Okay, so
Hmm.
in the Verilog, what you are doing means you are writing the code. Means you are describing your hardware in textual format.
Hmm.
Okay, and there is so here you are using some EDA tools. Okay, you are using
Hmm.
some EDA tools like Xilinx Vivado or Model Sim or Quartus
Hmm.
Prime. Okay, some
Hmm.
or Synopsys VCS tools. The tools, these EDA tools will convert your code into gate level netlist. Gate level netlist means your circuit is in terms of gates.
Thanks.
Gate level netlist. Okay, so that means here so I can write, so converting, so what are, this is very important, converting your code, converting the code, whatever the HDL code is there, into gate level netlist. Gate level netlist is called synthesis. Converting your code into gate level netlist is nothing but synthesis. And nowadays they are using C or C++ also for writing the code for this hardware like HDL. So this
High level synthesis, I guess,
yeah, yeah,
using
high level.
system.
This is high level synthesis. Yes, high level synthesis means what happens means so they are using C or C++. This C or C++ is converted into Verilog. Again, Verilog is converted into gate level netlist.
So why they are using high level synthesis? Like it is easier than Verilog, writing code in Verilog.
Yeah, okay, but means C or C++ means mostly we are writing the RTL code in behavioral modeling only. Behavioral modeling means
Yeah.
high-end modeling. High-end modeling means whoever the designers are there, they will nowhere bother about the internal circuitry.
Hmm.
Understood? So
Yeah.
means they will if you suppose the example half adder is there. Half adder means what it will do. I know how many number of input, two inputs and two outputs. I know the behavior of the circuit only.
Hmm.
Understood. I will not take bother about the internal circuitry. Okay, I will not bother about the internal circuitry. On the top level, I will write the functionality of the circuit,
Okay.
so that these software engineers also, they have some knowledge on this hardware. They can write in the, they know the syntax of C or C++. They can write in the high level modeling. So that is nothing but high level synthesis. Do you understood? Is it fine?
Yes, sir. It is
Okay.
also comes under digital design, right? The
Yeah,
part high
digital
level
design only, but they are writing the code in C or C++.
C C plus plus.
So normally what happens means this code is converting into Verilog.
So
Again,
Verilog.
Verilog again through the synthesis it is converting into gate level
Gate
netlist.
level.
Okay. Next, is it fine? Any doubts or queries?
No, sir. Yes, it's fine.
Okay. Yeah. Next, representing the design. Okay, this we will discuss in detail. Just I am giving one idea. Representing the of design. Okay, so basically there are like mm, uh, so five are there. One is switch level modeling. Switch level modeling. Switch level modeling means this is a low level modeling. Low level modeling means you are writing for CMOS circuits. Suppose the inverter is there. How we will design the inverter by using CMOS? So like this, you have PMOS and you have NMOS. These both are connected like this, and you are giving A, and this is VDD, and this is the supply voltage VSS or ground. You are taking the output Y. This is nothing but A bar. So low level of modeling is nothing but switch level modeling. Do you understood what is switch level modeling? For writing this
Yes.
transistor level is nothing but switch level modeling. Okay, and next you have gate level modeling, gate level modeling, and you have data flow modeling, data flow modeling, and next you have behavioral modeling, behavioral modeling. You have hybrid modeling also. Hybrid means what? You can use both the data flow and the behavioral modeling within
Yes.
within a code. That is hybrid modeling. Okay. So here, when you write this one in data flow and behavioral modeling, that we call as RTL, RTL code. RTL code is nothing but register transfer level, register transfer level. So normally, when you are converting into gate level netlist, it is converted in terms of D flip flops only. Okay. So how the data is transmitting through the registers is nothing but RTL code. So this can be synthesizable. This can be synthesizable. Means what? By using data flow modeling or behavior modeling, we can convert our code into what?
Gate net.
Net
The design.
hardware, design hardware. Yeah. So that means here, if you see the gate level modeling, so if you see the gate level modeling, you are using gate level primitives. Okay. Gate level modeling means you are using gate level primitives. Suppose you have AND gate is there. Okay, this gate level primitives means and or XOR,
Extra.
XNOR, all those things. So the syntax is like this. We'll discuss this. Gate level primitive, gate level primitive, followed by uh, gate level instance, gate level instance, and next output, followed by input 1, input 2, up to so on, like this. Okay, suppose you have a b are input and output is y, and gate level instance is y1 a1. Okay, so how to write for this one? So gate level primitive is and next and gate level instance is a1, followed by output y, output y comma inputs a comma b, like this you need to write. So did you understood the gate level modeling? Okay. Next, if you see the data flow modeling, So data flow modeling means uh, in terms of expressions we need to write. Okay. So you need to use a keyword called continuous assignment statement, that is assign. Continuous assignment statement, that is assign. Okay. So how to write for same AND gate? So this is my AND gate. You have the output y and a and b. So here you have y equal to that is a and b. With expression I need to write. Okay, I need to use assign statement. Assign y equal to a and b. This is nothing but bitwise and operators will discuss separately. So just remember this. This is a bitwise and operator. Did you understood?
Yes, sir.
So that means here, yeah, data types we will discuss. And next, behavioral modeling means what? You have a behavioral modeling. Behavioral modeling means here you need to use in the behavioral modeling you need to use the procedural blocks. Procedural blocks means you need to use the initial and always block. Okay, always block. Initial is non-synthesizable. Initial is non-synthesizable. Means what? We can't convert this initial block into hardware. Okay, but where we are using this initial block? In the test bench. In the test bench we are using the initial block. Okay, always is synthesizable. Always is synthesizable. Okay, and you have procedural statements also. Procedural statements means you are writing like if else. In C you already studied, no? Case, for,
Case equal
while,
while
repeat. Okay, these all are nothing but procedural statements. And for the combinational circuits, so you are, so blocking and non-blocking assignments are there. That also we'll discuss. Blocking and non-blocking assignments. Blocking and non-blocking assignments. This is a blocking assignment. Mostly we are using for combinational circuit, and non-blocking is this is non-blocking, and mostly we are using for sequential circuit. So so that means if you see the half adder, I know the behavior of the circuit only. That means you have a half adder circuit. You have two inputs. Let us take the two inputs are A comma B, and output is what? Sum comma carry. Okay. So I know the behavior of the circuit. This will add two bits, two 1 bit numbers, and it will give the sum and carry. So that means we know the behavior of the half adder circuit only. Okay. So we'll use these blocks, procedural statements, procedural blocks, and blocking and non-blocking assignments. That we will use. Okay. So we know the behavior of the circuit. Okay. We know the behavior of the circuit. That we'll discuss in detail. Just giving the idea about these modeling styles. And remember, if multiple statements are there, means you need to write between the begin and end block.
end.
Okay, like in C language, you are writing curly braces. Like that, if multiple statements are there, you need to write between the begin and end block. Is it
Yes,
fine?
sir.
Do you understood?
Sir.
Okay, yeah. So next, basic syntax. If you see the basic syntax, so before writing, before going into the programming, you need to know about the basic syntax. So Verilog will start with a keyword called module. Verilog code will start with a keyword called module, and this is case sensitive. You need to use lower case only. VHDL is not case sensitive, but Verilog is a case sensitive. Okay, and end module. It will end with the end module. Okay, so just you can see in the A module, or you can see in the Google. So keywords for the Verilog means you will get around 150 keywords will be there. These two are nothing but keywords, standard words. We can't use anywhere. So these are nothing but standard words. Is it fine? Keywords are nothing but what? Keywords. Keywords are nothing but predefined words which are in a standard library. Okay. So keywords are predefined words. Predefined words which are there in standard library. Is it fine?
Yes, sir.
Suppose if it is half adder is there. Half adder means how many inputs and how many outputs?
Two inputs, two outputs.
Two inputs and two outputs. Okay. So this is sum and carry. Okay. So how to write? So that is module, and so module name or identifier. Okay, HA, and here I need to write the port list. I need to write the port list. Okay. So this is a keyword. Module is a keyword, and HA is the identifier. And what are the port list? What are the inputs?
Input.
A, B, and S, comma C. Okay. So only semicolon will come after the bracket. Okay. Semicolon is nothing but end of the statement. Okay. Semicolon is nothing but end of the statement. And next you have end module. End module. Okay. After the end module, here no semicolon. Okay. Did you understood this? How to write the code? Okay. So rule. So this is nothing but we can call as identifier, or we can call as module name. We can call as module name also. Okay. So so one second. Yeah, rules for the identifiers. If you see the rules for the identifier or module name, you have invalid identifiers and valid identifiers. So what are invalid identifiers? Suppose I wrote the identifier for half adder. Okay. So like H space A, or it should not start with a number 2H space A, or next 2HA, or it should not start with a special symbol $HA, or it should not have the special character between these H hash A. Okay. So that means we can say that what are the invalid identifiers? We cannot use special symbols, special symbols, and special characters, and numbers at starting position, numbers at starting position. Okay. And gaps in between, gaps in between. These are invalid identifiers. Then what are valid identifiers? Suppose HA, this is valid identifier, and H small a, capital H small a, valid identifier, and HA2, this is a valid identifier. Okay, HA2, and HA2. Okay. Suppose underscore it will take, underscore HA it will take. Okay. Suppose 2 cross 1 mux is there. 2 cross 1 mux means what? It will start with a number, no? So if you are giving 2
Hmm.
cross 1 mux means the compiler will not take. If you give underscore means it will take. Okay. And next HA underscore, and next H underscore A, this will take. Did you understood? Invalid identifiers and valid
Yes, sir.
identifiers.
Understood. Yeah.
Understood? Yeah. So next port role declaration. Okay. Port list declaration. So port load declaration, there are two styles are there. First style one I will write. Style one, mostly like I'll write module, my identifier HA. I will declare the ports. What are the inputs A, B, and what are the outputs sum comma carry. Okay, sum comma carry, and next I'll declare. So that means input A comma B and output sum comma carry, sum comma carry, and end module. This is style 1. Okay, this is style 1. So you need to declare the ports. Input is a keyword. Here input is a keyword and output is also keyword. These two are keywords. Okay. So this is style 1. Style 2 is module HA. I can declare the inputs within the bracket itself. It will take input A comma B comma output sum comma carry, sum comma carry, and some lines of code I am writing, and end module. No semicolon. So these are the two styles. First you need to declare the port list. Okay. After that you need to declare the inputs and outputs separately. This is style 1. Mostly we will prefer this one only. So module, and my identifier or module name is HA. Input A comma B, output sum comma carry, and end module. Is it fine? Do you understood?
Yes, understood.
Understood. So next basic constructs. So basic constructs. You see the basic constructs. You have a system tasks are there. Okay, that we will discuss. Mainly dollar display. Dollar display. So dollar display. Uh, what is dollar display? It's like a printf in C language. You have seen printf in C language.
Mm-hmm.
Same like that. Whatever this in the double quotes that will be displayed. Okay, that will
Displayed.
be
Okay.
displayed in the TCL console. Okay, that will be displayed. Okay, in this you have some blank space is there. So blank space, if you want to get in the blank space, you need to use backslash b. Okay, if you want tab, backslash t. If you want to display in the new line, you need to use backslash n. Okay, and this is about the dollar display. And next, comments. What are these comments? Comments is there. This is increasing the readability, increasing the readability and understanding which are not executed by the compiler. Okay, understanding the instructions or lines, instructions. Okay, or command instructions which are not executed by the compiler. Okay, so which are not executed by the compiler. So there are two types are there. Like suppose a module, like if I write module and example. Okay, module example. So here like this I will write. Like this means this will be skipped by the compiler. Compiler will understand that this is a comment. Okay, this will not executed by the compiler. Did you understood this?
Yes, sir. Understood.
Okay, so you have a comments. In comments you have one is single line comment, single line comment. So single line comment means like it will be, the syntax will be like this. Syntax will be uh, so double slash SLC, single line comment. Okay, so that is nothing but it will be followed by double slash. double slash. So this is single line comment. Okay. And next one is multiple line comment. Multiple line comment. So multiple line comment is it will be like slash star, and some multiple lines are there. Okay, you need to give the multiple lines star slash. Okay, so this is nothing but multiple line comment. Okay, and nesting of comments is not allowed. Nesting is not allowed in the comments. Okay, not allowed. What is nesting? Comments under comments. That means you have multiple comments. Comment is closed. Here again multiple comments. Okay,
That
so
is
this is
not allowed.
not allowed. Is it fine?
Yes, sir.
So next you have operators. Operators are separately we'll discuss, but just remember that operators. You have unary operator. Unary operator means what? You have only one operand. Okay, one operand like not of A and of A. Okay, and this and of A. This is nothing but unary operator. And next you have binary operator. Binary operator means you have two operands. Two operands. Here you have like A bitwise and B, A bitwise or B, like this. Okay. And next you have ternary operator. Ternary operator. So ternary operator is like three operands you have. Three operands like C equal to A, again B, otherwise C, or otherwise the here you give D, or Y equal to. Okay, here y equal to A, that is equal to y equal to A. So that means if y equal to A, B is assigned to Y, otherwise C is assigned. Okay, like if else statement only. So like 2 cross 1 mux also you can use the ternary operator. Okay, suppose two inputs are there, let us take A and B. Okay, and Y and selection line. Okay, so that means Y equal to S. Okay, which one is connected? B, otherwise A.
A.
So that means
A.
if S equal to 1, which is connected? B is connected,
A.
otherwise A is connected. S equal to
A is
0,
correct.
A is connected. Okay, like if else statement only, but within the single line I am writing the ternary operator. Three operands will be there. Okay, so here it is fine. Shall I move forward?
Yes, sir.
Okay, yeah. Next, basic constructs in Verilog. Basic constructs in Verilog. Okay, so in the number systems we already seen number specification in Verilog. Number specification in Verilog. You have first binary. Binary, what is the radix? 2. And you have octal. What is the radix? 8. Okay, if n number is there, so radix is n. The range of the number is from 0 to n minus 1.
And
Okay,
minus.
n minus 1. And you have decimal, which is having radix equal to 10. And you have hexadecimal. Hexadecimal have the radix are equal to 16. Okay, suppose if it is a binary, first we will see the binary number system. Suppose if you, the syntax is like this. Syntax is how you represent the binary number is size tick. This is tick. Size tick,
Tick.
base and value. Size tick, base and value. Size is nothing but what? Number of bits in the value. Number of bits in the value. Okay. And base is nothing but you have, that means if it is a binary, base is B. If it is octal, base is O. If it is decimal, base is decimal base is D, and hexadecimal base is H. Okay. Suppose you have a number like 0011. Okay. So how you are representing? Tell me.
That is 3 now. Number
Ah,
of
this is
bits like 4.
this is
Yeah,
three only. But how many bits are there?
4.
Four. So size is four. Tick. This is which number
Base
system? Base. Base means what? B. And
B,
value. Value is what? 0011, like this.
1 1. Okay.
Okay. Suppose like 1111 000 is there. How to represent this?
This is size 8.
8 tick.
Tick O,
Binary. This
binary,
is binary.
binary, and
Binary. This
then
is binary only. This is not octal.
a value,
Binary only.
a value.
Binary, and this value. So 1111 and 0000. Like this will represent. Is it fine? Do you understand?
Yes, sir. Understood.
Okay. So next octal number is there. Suppose if it is octal number. So base is what? 8, no? Octal number base is
8.
8.
Yes.
Okay. Suppose 822 is there. How to represent this?
Number of bits 3 bits,
Hmm?
or we have to write 8 bits like
Suppose I told you like which is having the radix n. What is the range of the number?
n minus 1.
0 to n minus 1. I said the octal. Octal means 0 to 7 only. But here I
Uh,
indicated 8.
8.
Okay. So interior what we will tell, intentionally he will give the this number. Okay. You are saying something means you don't know the range. Understood? What is the range?
0
Range
to
is
7.
0 to 7. You need to say that this is a not valid octal. Why? Because the range is 0 to 7. Okay. Now suppose 722 octal is there. Is this valid?
The valid
Is this valid? Okay. How to represent size?
is 3 bits, sir. Size.
No. Actually, like octal, how to convert into binary?
Okay, we have to convert it
Octal.
in binary. Aha, okay. So
Two
we
cube.
have
2
to
cube
write
means
2 cube.
111
1.
010 no. So the size is how much? 9. Internally compiler will convert your octal number into binary. Okay. So size tick. So that is size tick, base
Value.
and value. Okay. So how it will be then means size is 9 tick. What is the base?
The
What is the base?
base
Tell
will
me.
be hexal. Sorry, it is octal, right? O.
Yeah, O. Base will be O, and value
The
is what?
value
722. Like
720.
this. Okay. Suppose 55 to the base 8.
We have to divide it like 101, 101, and then it is 6 bit.
6 tick. So
Octal
you can
O.
write octal O 55.
Hmm.
Okay. Suppose if I keep 8 tick octal 55, is this correct?
So
Suppose this is correct only. That means how many bits? This is 101 and this is 101. So total 6 bit is there. This value I am representing like this. That is 8 tick O55.
Is
Is there
also
any?
correct, sir. 0 1 it like 4 bits, like it is
Yeah, we
taking.
can add two zeros before that. The value will not change, no. So this is
Yes,
also correct. No error you will get. No error. Is it fine? Extra bits we can add. Okay.
yes, sir. Understood.
Next, you have this is second octal. Okay, this is second octal. Third, yeah, third decimal. Decimal. Okay, decimal having the radix how much? 10. Okay. Suppose 53 to the base 10 is there. How you can represent?
To base 10
Mm.
is decimal. So again, we have to convert into binary.
Yeah, 1, 2, 4, 8, 16, 32, 64. The number lies between here. So how many number of bits are required to represent 53? 1, 2,
Uh,
3, 4, 5, 6. 6 now? I told the shortcut for converting.
yes, yes, sir. Yes, sir.
Yeah,
6.
6. 6 tick. Base is what?
Base is D, decimal.
D and the value is 53. Okay, is it fine? So that means decimal is converted into binary and that size it will display. We need to display. Okay, and next last is hexadecimal. 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 What is base? Base is 16. Okay. F1 to the base 16. How we can represent?
We have to convert it to binary first.
Hmm. So within this binary, 16 equal to what? 2 power 4, no? So 4 bits. 1
4
1
bits.
1 1 1 1 1 1
1
0 0 0
0
1.
0 0 1 1.
How many bits?
12
12.
12 H
12 tick H FF1.
FF1.
Okay, FF1. Okay. Suppose like if you take the binary number tick binary 0110. What is the
Hmm.
size? Tell me.
Size will be 4.
Size are not declared, no.
Not declared, yeah.
Size not declared.
Either it can be 3 or 4.
3 or 4. How you are saying
Hmm.
that?
So if it is 110 or 0110, same.
Hmm.
Hmm.
But size are not declared, no. How will
Not
you
declared,
decide?
yeah. So the bit value is 0110, right? 4
Hmm.
bits.
But inside the compiler, it will be stored in how many bits? Size are not declared.
Hmm. I don't know that, sir, how many bits it will be.
It will be stored in terms of 32 bit. 32 bits. Okay. So that means most of the compilers. So most of the compilers will store are 32 bit only. Most of the
If
compilers are.
size does not mention.
Yeah, if size does not mention. Okay. So that means compiler will take a size as 32 bit. Okay. Will take a size of 32 bit. So what is the default size?
32 bit.
Default size is 32 bit. Okay. 32 bit. Okay. Similarly, octal also. Tick 073. Tick 073. What is the size?
Size we don't know, so it stores like 32 bit.
32 bit only. Okay. Tick H55. What is the size?
Same 32 bit.
32 bit. Okay. Now I will give, suppose 0 1 is there. Here I not mentioned the size and base. How the compiler will take?
On takes are invalid.
It will take, it will store.
So it stores in binary.
Okay, if it is binary, okay. I will give you 15.
It always stores in binary, I guess. That normal default
But 15, yeah, 15 default, that is the size. Related to
size.
size,
Okay.
already told no. Size, what is the default
Size
size?
32-bit.
Size
32
is
bit.
32 bit. I'm asking the base.
Base it stores in binary, I guess.
But 1
Default.
5 is not a binary, no.
Not a binary, yeah.
Either suppose 0 1 means from here you can say that this is binary, but 1 5 is not a binary. No? Suppose like 1 8 is there. If it is octal, 8 will not come.
Don't know, sir.
So compiler will take the decimal default size, default basis decimal. Okay. So this you need to
Default base
remember.
as decimal.
Compiler takes as decimal, decimal to avoid confusion. To avoid confusion. So that means the default size is 32 bit and default base is decimal. Okay. So that
Decimal.
means this decimal will be converted into binary only. That size will be displayed. Okay. That size you not declared means 32 bit only. Normally it will store in terms of 32 bit only. So that means here 15 means what? So internally how it will store means 1 1 1 1 again, so 0 0 up to so on. This is 0. So this is
32
0 is the
0.
bit and this is 31 bit. Like this it will
31st
store.
bit.
Okay. So like this it will store. Okay. And next you have special characters. Special characters. You have X. X is what?
X is invalid.
Invalid or don't care. In digital we already seen, no?
Don't.
Don't care or unknown value. Unknown value. Okay. So what is the value of don't care? We can say that it you can take as 0 or 1. No?
1.
0 or 1. Okay. Next Z. Z is nothing
Red
but what?
unknown.
Impedance. No.
Impedance, yeah.
Okay. This that means here this is if we represent anything is unconnected state. Okay. So if we represent anything in unconnected state, connected state, that is nothing but so like you have a wire. So this is in unconnected way. Okay, this is nothing but in analog part also we already seen no high impedance state
Low
for the
impedance, yeah.
high impedance and low impedance for the transistors we already seen, no. Is it fine?
Yes, sir.
Special characters. And next strings. Strings. Okay, strings. So what are strings? Strings are a sequence of characters enclosed in the double quotes. Okay, so strings are sequence of characters, sequence of characters um, enclosed in double quotes, double quotes. Okay. Suppose like uh, Verilog HDL is there. Okay. So each character will take how many bits?
32 bit.
Each character will take 8 bits. Okay, each character will take 8 bits. Okay, so that means 1 2 3 4 5 6 7 7 eights 7, again space will become, okay, 8 9 10 11, 11 eights, sir. So it will take how many bits?
8.
88 bits. Is it fine? Do you understood?
This default, sir, each character will
Yes,
take
yes.
8 bits.
Inside each character string, it will take as 8 bits. Normally, it will be stored in terms of ASCII. In digital, we already seen now. American Standard Code for Information Interchange. That is means characters. Characters are that will be stored in terms of ASCII. During the course, we discussed about this uh, special characters and all those things have a ASCII value. Okay, so that will be stored in terms of 8 bits only. Okay. Next, you have value set. Value set. So value set, you have first 0. 0 means what? Logical, low
Oh,
or false condition. Okay, false condition. And you have 1 logical, high or true condition. And next you have X. What is X?
valid, don't care.
Don't care. Yeah, don't care. Z, high impedance. These are the values set. So coming to Verilog, it will support so data types. We'll discuss data types in the next class. It will support 4-state data type. 4 states will be there in the Verilog. Okay, so it can be 0, 1, X, Z. In Verilog, it will support. These are the value set. Either 0, so value can be either 0 or value can be 1 or value can be don't care or value can be impedance, high impedance. That is Z. Is it fine? Do you understood any doubts or queries?
No, sir, understood.
Okay. So we'll stop here. Next class we'll start with the data types. Okay.
Yes, sir.